Hello guys, in this video lecture we are going to discuss the interesting facts, uses, types, classification of concrete. We will discuss the different classifications like ordinary cement concrete, high strength concrete, special concretes, plain cement concrete, reinforced concretes and special concretes including FRC, RCC, PC, FC, and what are these stands for, these terms in detail in upcoming slides. So you are requested to please watch the full video and don't forget to subscribe, like and to press the bell icon to get more video updates. So let's start our today's topic. First of all, classification according to strength. According to strength, it is classified as ordinary cement concrete and high strength concrete. Ordinary concrete has a varying strength from about 10 megapascal, that is 1450 psi, to about 40 megapascal, that is 5800 psi. The other classification of concrete according to strength is high strength concrete. High strength concrete has a compressive strength generally greater than 6000 pounds per square inch, that is 40 megapascal is equal to 5800 psi, as the bracket for ordinary cement concrete is 5800 psi, and the concrete having strength less than 5800 psi is called as ordinary concrete, and the concrete strength greater than 5800 psi is called as high strength concrete. High strength concrete is made by lowering the water cement ratio to 0.35 or lower than 0.35. Now classification according to design. Plain cement concrete. Now it is the classification of concrete according to design, which is called as PCC or plain cement concrete, and other one is reinforced cement concrete. In short form it is called as RCC. As you can see here, this is PCC, that is in which no steel reinforcement is provided. As you can see here, the lean is provided, or you can say the base is provided for the raft foundation, in which no steel is provided, is called as PCC or plain cement concrete. And reinforced cement concrete, in which steel reinforcement is provided to give tensile strength to the concrete. As you can see here, or the concrete we provided in the columns, beams, slabs and raft foundations, etc. So the concrete containing steel as a reinforcement is called as reinforced cement concrete. So this was the classification according to design. Now classification according to qualities, which are also called as special concretes, which means that these concretes are made for special purposes and to fulfill special purposes. First one is polymer concrete. In short form it is called as PC, polymer concrete. SC, it is sulfur concrete. RCC, again it is special concrete. The one we studied in the previous slide, it was RCC, which is called as reinforced cement concrete, and it was classification according to, as you can see here, RCC classification according to design, and it is called as reinforced cement concrete RCC, whereas this RCC is called as roller compacted concrete, and it is special concrete. Fourth one is ferrocement, and fifth one is very high strength concrete or HPC, that is high performance concrete. We will discuss these special concretes one by one in upcoming slides. The first one, polymer concrete. Polymer concrete is prepared by mixing synthetic resins or polymers as a binder with an aggregate. The polymers are polyethylene, that is PE, polystyrene, polyvinyl chloride, etc. Polymer concrete is costly and is used for chemical resistant pipes. It's mean that you cannot use polymer concrete for ordinary construction, but it can only be used for chemical resistant pipes, lightweight drainage channels, for quick repair and strengthening applications, and for structures subjected to corrosion and erosion. As you can see here, these pipes are prepared for chemical resistance. Chemical resistance pipes are prepared using polymer concrete, and as you can see here, cracks are being filled with this solution that is for quick repair and strengthening applications. The next type of special concrete is sulfur concrete. SC is short form for sulfur concrete. SC mix usually consists of sulfur, that is 2% by weight, fine aggregates, that is 32% by weight, coarse aggregate is 48% by weight, and a mineral filler such as crusher dust or silica floor is used to make this sulfur concrete. The mix contains no water or cement. The ingredients are mixed in a conventional mixer which contains a heater at a temperature of about 140 degrees centigrade. After mixing ingredients from a uniform mixture which can be cast into molds. Now this is the very interesting fact about sulfur concrete, that no water or cement is used in sulfur concrete. The ingredients, as I mentioned here, is heater at a temperature of 140 degrees centigrade, and after mixing the ingredients were, as you can see here, sulfur, which is 2% by weight, and aggregate is 32% by weight, and coarse aggregate is 48% by weight. These all ingredients are mixed at a temperature of 140 degrees centigrade, and after mixing it forms a uniform mixture which can be cast into molds. Sulfur concrete gains strength very rapidly and attains about 90% of its ultimate strength in 6 to 8 hours under normal conditions. This property makes it suitable for use in precast units. When used with acid-resistant aggregates such as granite, it is unaffected by continuous exposure to acids. The material is brittle, hence unsuitable for structural applications. Sulfur is highly unsuitable for fire resistance quality because of its low melting point, that is 119 degree centigrade. The third type of special concrete is roller compacted concrete. Roller compacted concrete is used for the construction of dams, heavy duty pavements, and parking areas, that is, a structure subjected to heavy loads. Roller compacted concrete is a special blend of concrete that has the same ingredients as conventional concrete but in different ratios. RCC concrete is same as that of conventional concrete, but the ratio is different. It has cement, water, and aggregates, but RCC is much drier and essentially has no slump. RCC is placed in a manner similar to paving, often by dump trucks or conveyors spread by bulldozers or special modified asphalt pavers. After placement, it is compacted by vibratory rollers, as you can see here, the picture, that is, the dumper or truck or conveyor belt is used to convey the material from one place to another, and it is spreaded by bulldozers or special modified asphalt pavers. As you can see here, here is the modified asphalt paver, because this concrete has no or zero slump and its workability is very low, and it's very difficult for laymen or laborers or workers to spread the material. So the modified asphalt pavers are used, and after placement it is compacted by vibratory rollers, as you can see here in the picture. RCC is typically used for concrete pavement, but it is increasingly used to build concrete dams because the low cement content causes less heat to be generated while curing than do conventional massive concrete pours. For dam applications, Roller compacted concrete sections are built lift by lift in successive horizontal layers. Now it is discussing for dams, that is dams are constructed in step by step process and resulting in a downstream slope that resembles a concrete staircase. As you can see here, the layer by layer concrete is placed, that is with no slump concrete, that is workability of concrete is very low, that concrete is placed by layer by layer, and the bottom of the wall is much more thicker than the top of the wall, and it resembles a concrete stairs. Once a layer is placed, it can immediately support the earth moving equipment to place the next layer. After roller compacted concrete is deposited on its left surface, small dozers typically spread it in 1 foot thick layers, that is maximum 300 millimeter layer of a concrete can be placed, and then it is compacted by small dozers. Fourth one is fiber reinforced concrete. FRC is manufactured to increase the tensile strength, impact strength, fatigue strength, and resistance to corrosion. The ingredients are cement, fine and coarse aggregate, and discontinuous fibers, that is, small pieces of fibers will be used. The fibers are made from steel, glass, carbon polymer, and asbestos. As you can see here, this beam was casted just to check the strength, that is the change in strength after the adding of the fiber, and steel fibers are used after. As you can see here, the beam after the cracking, the steel fibers are visible, and these plays a considerable role in increasing the tensile strength of the beams or any structural member. Fibers are added at the rate of 0.6 to 0.9 kg per cubic meter of concrete. Now this is a very minimal quantity, as you can see here, that is 0.6 to 0.9 kg per cubic meter. Ferrocement is composite material which is used in building or sculptures with cement, sand, water and wire mesh or mesh material. The steel frame is made according to the geometry and shape of the structure. The desired shape may be built from a multi-layered construction of chicken wire or other steel mesh if needed, reinforced with steel wire or steel bar. As you can see here chicken wire mesh is used to give the aesthetical look to any sculptures or any structure you are making. So these are actually not load bearing structures. Over this finished framework, an appropriate mixture of cement, sand and water is spread out. During hardening, the ferro cement is kept moist to ensure the cement is able to set and harden. Ferrocement technology is widely used around the world as a good method for building large water vessels for fresh water supply. Ferrocement consists of a thin sheet of cement mortar which is reinforced with a cage made of wire mesh and steel bars. As you can see here, this structure is composed of wire mesh and steel bars. The wire cage is set in a wet cement bottom foundation and then plastered on both sides. Because ferrocement is structurally more efficient than masonry, the thickness of the walls of the container are as low as 10 to 15 millimeters. Ferrocement requires only a few easily available materials, which are cement, sand, and galvanized wire mesh. This tank is being constructed to catch roof runoff for portable use and also for irrigation of gardens, addressing two issues at once, that is secure clean water supply and extra water for gardening. This method has really become popular in the area after the workshop with Scott Pittman at IMAP. Last but not the least, and the last number 6 special type of concrete is high performance concrete, HPC. High strength or high performance concrete is used in bridges, highways and buildings. The strength varies from 70 to 140 megapascal, that is 10 to 20 ksi, which is kilopound per square inches. High performance concrete usually consists water cement ratio from 0.27 to 0.50, and a super plasticizer cement content is from 392 to 557 kg per cubic meter. In buildings, column sections can be reduced in size. The amount of reinforcement can be reduced. That is, if you are using a high performance concrete having a water cement ratio within the range of 0.27 to 0.50 and a super plasticizer is used in this range, the sizes of the columns can be reduced, and the reinforcement can also be reduced. High performance concrete increases durability, enhances mechanical properties. As I mentioned here, that these concrete are mostly used for bridges, highways, and for precast structures. So that's all for today. In the end, you are again requested, if you are new to my channel, please subscribe it and press the bell icon to get more video updates.